Hi everyone, welcome to the 15th meeting of Cryptography Club. This is the last meeting for this year, 2023. In this meeting, we're going to talk about the hash algorithm. So we're going to go through the introduction, applications in the field of cryptography, applications in data structures, and Python implementations of the hash algorithm, and then customize hash functions, and then the hash function, the built-in hash function, and the built-in hash lib module. So first is the introduction. The hash algorithm transforms an input of indeterminate length into an output of constant length, a hash value, by means of a hash function. The hash transformation is a one-way operation which is irreversible, and the information cannot be restored according to the hash value. So strictly speaking, the hash algorithm is a message digest algorithm, not an encryption algorithm. Some common hash algorithms are SM3, MD5, SHA-1, etc. So let's look at an example of the MD5 hash generator. In this generator, we can put a string, or it can contain numbers as well, and it can be any length, and it will generate an MD5 hash. So we could say that we are in room 222, and it generates an MD5 hash string. We could copy this and then put it into our code to see how long it is. So we can test it. And then because we printed the length, its length is 32. And then for another test, we could change the message, and then such as using Chinese, we say hello in Chinese and generate an MD5 hash for it. And then we could see that the length of this new hash, we can see that it's also 32. So now we know that for the hash values for different messages are all the same length if it is using the same algorithm like MD5. So there are 16 to the power of 32 possibilities, because the hash that we got is not in decimal format, it's in hexadecimal format, because there were like letters in it along with the numbers. So for each place, there are 16 different possibilities, and there are 32 digits. So there are 16 to the power of 32 possibilities. And if we change that into binary, 16 equals 2 to the power of 4, and then 2 to the power of 4 to the power of 32 equals 2 to the power of 128 different possibilities, which is a lot of possibilities. That means that it's really hard for two different messages to have the same hash value. Next is the application. Hash is usually used in data structures and in the field of cryptography. In different application scenarios, the considerations for the hash function would be different. So if we are managing data structures, the main consideration is the speed of operation and to ensure that the hash is evenly distributed. But if we're in the field of cryptography, the priority is collision resistance. to avoid the situation where two different plaintexts have the same hash value. So data structures are like different types of data. So if we're just wanting to keep the data, then it is to have a good speed. But if we're wanting to put it in cryptography to make sure that to ensure that it is right and correct, then the priority is to make sure that different messages don't have the same hash value. So more in depth about the applications in the field of cryptography. In cryptography, the role of the hash algorithm is mainly for message digesting and signing. In other words, it's mainly used to check the integrity of the whole message. For example, some login sites do not store the user's password directly in plaintext, but store a hash processed summary of the password, which is the hash value, so that when the user logs in, they only need to compare the summary entered in the plaintext with the summary stored in the database to see if it's the same. Even if hackers invade or maintenance personnel access the database, they cannot obtain the user's password in the original plaintext, so it improves the security. So for cryptography, it's just to ensure that the message is correct, but it doesn't care what the actual message is. That way, no one can know what the actual message is, and it makes it safer. For applications in data structures, the data structure that uses the hash algorithm is called a hash table, mainly used to improve the efficiencies of queries. It accesses the records by mapping the key code values to a location in the table using a pointer to speed up the search. The mapping function is the hash function, and the array that holds the records is called a hash table. When applied in data structures, sometimes a higher computing speed is needed instead of collision resistance, so you can use a hash function of your own construction. And let's look at an example to see what the speed means. If we don't use this hash array thing, then if we have a lot of numbers, originally we would put it in a simple array, like connecting all of them in a list with commas. But now, if we want to increase the speed, we can use pointers to connect different numbers together. So, for example, if we have the data 496, we can connect it to the end of 0 because 496 divided by 16 has a remainder of 0, so we connect it behind 0. Similarly, 896 divided by 16 also has a remainder of 0, so we can just add it to the end of this line. For other numbers, such as 1, which has a remainder of 1, it goes behind 1. 387 divided by 16 has a remainder of 3, so it goes behind 3. And then for each number, we can divide it by 16 and find the remainder and then put it in the line of the remainder. That way, it makes it easier to add elements into this array or table, and it will also be easier to find a certain element. For example, if we want to know where the number 111 is, we can divide it by 16, find the remainder, which is 15, and then just look in the 15 row, and then we can find it very fast. So this method of transforming elemental features into array subscripts is the hashing method. So changing this element into a place where we can find the element. A simple example is this example where we mod by 16 and give that value to the index. In this example, it's 4 to the power 2 to the power 4, which means that it is 4 digits in binary, which means that the hash value has only 4 digits. So it is very simple, and in real life it would be a lot longer. Next is the custom hash functions in Python. So because it's custom, we can do anything we want to it. Some methods are divide and find the remainder, phase shift, hash loops, square the number and then split the number in half, etc. I've created the following custom hash function. So in this hash function, the first line says that the coding is in UTF-8, which just means that all of the data is in this coding, so we don't need to worry about it. This is the default coding, and this is to explain that we're creating a custom hash function. And then here is the function that we're creating. Its name is called myHash, and the parameter is x. When we run this function, it will return x mod 7 XOR2. And then the XOR, it means exclusive OR, which is a Boolean logic operation widely used in cryptography, as well as in generating parity bits for error checking and fault tolerance. So basically, if we do here, let's look at the first example. When we run this function with 1, first we do 1 mod 7, which equals 1, and then do 1 XOR2. This means that this XOR is an operation. We first turn 1 and 2 into their binary numbers because this operation only works in binary format. So in order to turn 1 into a binary number, we know that in binary, the 1's digit is 2 to the power of 0, and the 10's digit is 2 to the power of 1. So 1 equals 2 to the power of 0. So that is just 0, 1. And then 2 in binary equals 1, 0, because it is 2 to the power of 1 plus 0 times 2 to the power of 0. And then in order to do this XOR function, we stack them on top of each other and then see if each digit contains 2 of the same things. In this, the 1's digit, the 1 and 0 are different. So when they're different, we put a 0. If they're the same, we put 1. But in the next digit, they're also both different, so we put another 0. Never mind, I said it the wrong way. If they're different, we put 1. So they're both different, so we put 1, 1. And then we turn this binary number back into the decimal format. So this equals 2 to the power of 1 plus 2 to the power of 0, which equals 3 in decimal format. So the output is 3. And then for the next example, we do myHash2, which when we put it in, it is 2 mod 7, which equals 2. And then we do 2 XOR2, which is 1, 0, XOR 1, 0. And then we stack them again. But this time they're the same, so we do 0, 0. And then this 0, 0 back into decimal would equal 0. So this output is 0. And then for 3 mod 7 equals 3, and then 3 XOR 2. This 3 in binary equals 2 plus 1, so it's 1, 1, and then XOR 1, 0. We stack them on top of each other. This is different, so 1. This is the same, so 0. 0 and 1 back into decimal equals 1, so the output is 1. And then lastly, 4 mod 7 equals 4. 4 XOR 2 turn into binary. So now 4 equals 2 to the power of 2, so we gotta look at the next place value. So that equals 4 equals 1, 0, 0 in binary, and then 2 is 1, 0. So now we compare these two, 1, 0, 0, and for 1, 0, we need to add a 0 for this place. So 0 and 0 is the same, so that's 0, this is 1, and this is 1. And then we turn 1, 0, 0 back into decimal, so that's 2 to the power of 2 plus 2 to the power of 1, which equals 4 plus 2, which is 6. So the output is 6. And then let's look at test the code. Yeah, so it got the same result as us. It printed 3, 0, 1, and 6. So we have now defined our own hash function. Next, let's look at the built-in hash function. There's a built-in function in Python which returns the hash value of an object. It could be number or strings, but it cannot be directly used on lists, sets, or dictionaries. The sample code is as follows. So the coding is still in UTF-8, but now we're doing hash. We can find the hash of 1, 1.0, the string ABC, and the string hello world. And then we can do that in the code. And then it prints out the hash values of all of these. And we can tell that even though the data types for 1 and 1.0 are different, the result for the hash is still the same. Also, if we do the same thing twice, the hash result is the same, because that's how it's supposed to be. And then the hello world has its own hash value as well. These two are actually the same length. It's just this one has a negative sign in front of it, so it looks longer. So for the analysis, there's a phenomenon that we said the hash value of the same string is the same in the same run, but the hash value is different in different runs. So if we run it again, we get different hash values. This is because Python's hash algorithm has a mechanism to randomly generate secret prefixes or suffixes at startup, and there's a randomization. For the same string input, different interpreter processes may get different hash results. So if we use the built-in hash function, every time we run it, we will get a different result because it generates these prefixes and suffixes that it doesn't tell us. So if we need a reproducible hash that is consistent across processes, we will need to use the hashlib module. So this is another built-in thing in Python for hash. This provides common digest algorithms such as MD5, SHA-1, etc. The sample code is as follows. So we're still using the UTF-8 coding, but now we're using the hashlib module. We first import the hashlib module so we can use it, and then we do hashlib.md5 and give that to the MD5 variable. So this is applying the MD5 algorithm. And then let's look at the code because I made some changes. So the first line is applying the MD5 algorithm, give it to the variable MD5 1, and then we print the type of MD5 1. This is MD5 is an instance of an object, which you don't need to understand because it's very complicated, and then it will print that it's a class. So it prints that it's a class. And then we give the hello world string into data, and then we encode the data, and we also tell it that it's UTF-8, and then it will update this encoded hello world into the MD5-1 variable, and then it will use, and then we do MD5-1.hexdigest, which basically finds the hash value of this, and then we print it. So we have found the hash value using MD5. So this is the built-in hashlib module, and no matter how many times we run it, we will get the same result. So we use that when we want to have like a reliable hash generator. And that's it for the video. Thank you for watching.